Hello and welcome to another one of my videos. In this one, it's about time we got to testing some of these motors now that we've got our pulley ready to do it in the last video. So let's get to testing. Now I have divided the motors that I have scavenged into different groups. The first ones we'll test are the ones with 2 contacts or 2 wires. Then we have some that sometimes have 4 wires, but they spin freely. Because there are other ones like this one that have 2 wires but they don't spin freely, they sort of go because they're stepper motors. Ones with 4 wires like these square ones, or those ones, they are stepper motors and we'll deal with those later. They're a particular kind. Ones with 5 wires and even 6 wires are the same. We can still use them, but we'll look at them later. Most of the ones I have rescued have pulleys already from the apparatus they were in, so we'll test those first by placing them where the string from the pulley is going to go. Then I'm going to get either a stick like this and cut a V in it if I haven't got something to cut an archway like that, so that it can go on top. So it's going to anchor it, and with a clamp that down so that that will be secured to the table. Now I was given a multimeter for a birthday once, so I actually have one, so we can test with the multimeter these motors. And with some alligator clips I'm going to just connect up the wires, or the connections, whichever is, and giving it a spin. And with the voltmeter on the 20 volt setting, we can see that we're comfortably getting 5 volts. If I spin it one direction, go in the opposite, and it will give me 5 or 6 volts. It's more or less the same in reverse. And if I go, that's direct current. If I go to AC current, alternating current, it's giving me about 10 volts in one direction and nothing in the other, which is quite interesting. And if we go to milliamps, let's see what's giving us in a dead short. Only 3 milliamps, which is not a lot. If we go to the 20 milliamp, okay, yeah, 3 milliamps, which is not a lot of current. So that means if I now connect that to some LEDs, LEDs need about 3 volts, and I've got 5 with this, and yes, quite happily it will light 10. Let's see how well it does 50. So also we have enough voltage, because it's 5 volts, to run 50 LEDs, but the ampage, or the current, is not that strong to light them very brightly. So let's try the next one. It's a longer, skinnier one. Okay, and we're going to connect the connections to just some contacts, 2 contacts at the back. It's easier to do it before I connect the other. Put that on and clamp it down, and we should be right. And then we give it a good spin to see what we've got. And it looks like we've got around about 8 volts in a positive direction, and roughly the same in the other direction, in the negative direction. If we go to AC current, see what it's got with that, and that's giving us double as an AC current. And in the amps, we're actually getting 2 whole amps out of this at 8 volts, or AC. I mean, it does AC as well as DC, so that's interesting. That will be a useful motor. Now with that extra voltage and that extra current, it's giving us very bright lights, probably a little bit more than the bulbs need. They only need 3 volts, not 8, but that's okay. And if I connect it to the 50 LEDs, it actually burns quite nice and brightly. Ample. In fact, there's probably more ampage than they need right away, and I can store some of that. So it's a good motor. Now, considering the motors that have the 4 contacts, these are the DC motors, direct current ones, that spin freely rather than having, like these ones, a resistance that goes. Those are stepper motors. Look at those later, the ones that spin freely like this. It means that basically it has two windings, usually one for slow and one for fast. And so they have two sets of coils in there. Now, by trial and error, I have found some pairs. And in this case, as you can see, it's very low voltage, only a little over half a volt in one direction. But if you go the other direction, it's giving us 3 volts. Almost 4 sometimes, which is enough to light an LED. And if we go to the ampage, it doesn't give us much on amps. It gives us a very low ampage also of only 2.9 milliamps, is it? And AC current, nothing. In one direction it gives us 6 volts of AC current and nothing in the other direction. Interesting. And I was right, it can light 10 bulbs, but barely. So that's not such a good motor, that one, on those 2 windings. But if I go with the other 2 wires and connect those up, let's see, back on volts, I get 3.7 in that way and 4 volts in the other direction. AC, nothing in one direction, and 8 volts in the other. And milliamps, 25 and 190 milliamps in the other direction. So those are the 2 wires in that direction that I want to use it. So yes, I was quite right. Those are the 2 wires that are going to give me the best results on this motor. And it will actually light the 50 LEDs quite reasonably, actually. Now, last but not least, I'm going to, just as an academic exercise, test this little motor. Got the wires going out down to the thing, and I'm going to just run it on the pulley here. See what sort of voltage we get. So we're getting about half a volt, and how many milliamps? We're actually getting 34 milliamps of power at half a volt. Even that little thing. Impressive, isn't it? So there we have it, a few tests on a few of the 2-wired motors rescued from electronics and old stereos and tape recorders and things like that. And they've given us anything, as you saw, from half a volt, which, and voltage, for those who don't know, is the pressure that the electricity is under, and the amperage is how much current is actually flowing. So you get a combination of those. We'll look at that later on. And we've got anything from, in the amperage of current flow, from 6 milliamps up to 2 amps, which is quite a bit, but with lower voltages, I would say. So let's, in the next video, actually make some, what do you call them, machines that puts it into practice.